So we'll continue our look at limits, and in this first problem we're looking at the limit of this rational function, and the rational function is actually a ratio of polynomials. So as before, we could use substitution to evaluate, and if we do that, we substitute x equal to 3 into each of the polynomials, we see we end up with 0 over 0. 0 over 0 is called an indeterminate form, and what that means is we have no idea what the limit is. The limit really could be anything. So we have to look a little bit further at this function, and in fact we're going to use some algebra on this simple function to see if we can understand what the limit actually is. So that's what we're headed towards. Okay, so we are going to do just a tad of algebra on this rational function. And so since the numerator is a polynomial, it makes sense to try to factor it. It's very easy to factor. It factors in this way. And so that's a very convenient thing, very nice thing, because what happens is you can see x minus 3, oh whoopsies, I forgot to put that in. So as you can see, x minus 3 is a common factor. And so x minus 3 over itself is a 1. It's a 1 really often, almost all of the time. In fact, it's 1 all of the time. The only time it's not 1 is if x is actually equal to 3. But in the limit, x is not actually equal to 3. X is only close to 3. So this is a 1. And so what's left, if we cancel that out, in effect, we can look at the limit as x approaches 3 of x plus 1. And this is, we can evaluate this with simple substitution. We end up with 4. So 4 is the result. And 4 makes sense in terms of what this function looks like when we look at the graph, because, let me make this a little bit bigger. When we look at the graph, I have this window, I changed it a wee bit. When you graph the function, if you do zoom decimal, which is zoom 4, the window, it's not perfect because the y-axis doesn't actually include this point. But if you change the y-axis, I think I had y-min at negative 1.1 and y-max at 5.1. So if you change it just a wee bit, then in this window you can see very clearly that the function, the graph of the rational function is linear, which makes sense. But however, there is a hole in the graph, and the hole in the graph occurs at x equal to 3. So really this function that we started with, we can think of it, an alternate definition of this function as it's x plus 1 provided x is not equal to 3, and at x equal to 3 this function is undefined. So our original function is mathematically equal to this piecewise defined function. And we can see as we approach 3 from below, all of those x values are mapped via the function to the line, and those y values get very, very close to 4. And if we're approaching 3 from above, those values get mapped via the function to this part of the graph, and those y values are also approaching 4. So graphically and numerically and algebraically, in all of these ways, we see the result here is 4.